Good afternoon, everybody. It's the webinar time, and we wait about 5 minutes for the last attendees to join. And we start at 4:05.
Good afternoon as well. So I see we're being joined by more attendees, and we are waiting, I think, a dozen more. But we can begin maybe with a little talk about what we are going to discuss later today. So I think the distribution of solar systems is a topic which is hot enough, and from the list of attendees I can see actually from all over the world. We are seeing here from Europe, US, I think also even Africa, but mainly European Union. So it's a good point to see that actually everyone is quite interested in the topic regardless of their location worldwide. Igor, what can you say about this?
Not much.
I think we are waiting for your presentation mostly.
Yes, but I believe that there are more people coming, and it will be wait for them.
I think some of them were invited by me personally, so I can see here.
Many familiar names. It's very good to see everybody.
Yes. I think most of the audience is from Europe. We have also quite nice representation from Israel, US as well.
I see more people are coming. Would you like to wait more?
It's a good question. Indeed, people are coming all the time. But I suppose at a certain moment we would have to start anyway. Let's give it a couple of more minutes. Maybe just talking about the general topic we're going to discuss, the trends and challenges. I think I've just recently seen data for 2020 about the situation in the COVID year with distributed PV versus utility scale. So overall PV seems not being hit that much by the pandemic, but actually we are seeing a little bit more growth in the utility scale, a little bit less in the distributed solar PV, but still both are growing, which is an exceptional thing for the entire industry. And the energy industry has been hit hard over the past year, even actually recently with the disruption in the Suez Channel. So I think it's overall, if 1 year ago, some people considered solar as something being impacted by the pandemic itself, I think now the growth basically has not been impacted at all over the past year and probably in the years to come. In some countries, we actually see the contrary. We actually see that solar PV is being accelerated for various reasons. I think we must mention some specific markets like Poland, which is experiencing hypergrowth. Also some other countries in Europe, but of course United States, which installed a double-digit number of gigawatts last year. Still more than 50% utility scale, but also a lot of residential and commercial is also picking up. So I think we can start with your presentation. Dr. Derzy, please.
Okay, so good afternoon, everybody. My name is Igor, Dr. Igor Derzy. I'm a chemist, physicist, and attorney at law. I support with legal services and also with professional services through my company called VTS Energy. I will be talking about distributed photovoltaics. And most of the people here probably know what it is. And basically, it is an operator or aggregator that collects electricity from many, many roofs and sells it with profit to the grid, hopefully with a profit. There are obvious differences between the utility scale PV and distributed PV, but there are two differences that drive people much towards the distributed PV business model. And they are the tariffs, that distributed tariffs provided by government are about 3 times or even more higher than those at utility scale. And the other advantage is that you don't need to put all the capex in advance. You can build your business gradually, roof after roof, which is also an advantage and makes the distributed PV business easier to enter. And if you look at the trends, indeed, there is a growth trend, a worldwide growth trend, having distributed PV taking more and more percentage out of all PV production. This is a slide to show that good and big countries are all into distributed PV. There are several operation models when you are in the distributed PV business. 3 of them are here. I'll explain them. In the first one, the roof is owned by a roof owner, and he builds the photovoltaic system, he maintains it and sells himself the electricity. And roof owner is not a small roof owner only. It can be a pretty large owner like a municipality, and you will hear Dr. Noam van der Dr. Noam van der Hal talking on behalf of the roof owners. And in other model, the roof still owned by the roof owner, but the roof owner hires an operator to maintain and construct the photovoltaic system. And in the third model, there is an aggregator that runs around, rents roofs from various people and businesses, puts his own systems on them, sells and collects the payments, and he pays the owners the rent money. So a guy comes to me, a customer, and says, look, this is a bonanza. Look at the IRR, it's 32%. Look at my Excel. And I say to him, this would be nice in a perfect world, pink and perfect. But the real world is not such perfect. It's full of rain and bad weather. And this is a world of low tariffs, high operation and maintenance costs, and I'm talking a lot of performance degradation. LNRG technology performed a study, and we are talking about 0.5% up to 4% of annual performance degradation for a system, which is quite a lot. So we put up a model, an Excel model, and we performed the sensitivity analysis to see how the business performance of a system is dependent on losses and operation and maintenance costs. And as you can see, there is a very narrow area that you can barely be, which is not barely, it's a lot, but you can barely be profitable. And if you look other way or sleep or drink too much, you very fast go to losses. So of course, operation and maintenance and degradation and losses are two-way businesses. By definition, you maintain your system to reduce the losses and degradation. So you have to find the middle line to stay profitable. So what you need to do is reduce manpower costs, optimize maintenance, and simplify your monitoring. And also creative funding would help, but as a law professional, I will not speak much about it, since there are models of funding that are very marginally legal. That's it for me. We will wait for questions and answers to the end of the seminar. And the next speaker will be Mr. Leon Kraversky, the CEO of Soltell, and he will tell you how his company helps with reducing the operation and maintenance margins.
Thank you, Dr. Derzy. So let me share the screen with you. So I will speak about operation and maintenance, and I will also add some insights on the supervision of operation of such facilities. But a little introduction for myself. My name is Leon Kraversky, and I'm a graduate of a master's degree in nanotechnology with expertise on PV devices. So actually I got into this world some 13 years ago, which is quite much of a period. And over the years, I've been exposed to various procedures and long-term influences on the performance of such facilities, specifically distributed solar facilities, which are mainly rooftop. Let's be clear about it. And this led us, me and my team, to develop Soltell and its smarter solar management solution, which deals with quite several levels of problems in operation and maintenance of such facilities. So first of all, what we do is we provide solutions for supervision as well as operation and maintenance for solar PV. And this is governmental, commercial, and residential scale as well, even though our main work is in the commercial sector. Now let's talk about the problem, which has been just introduced by Dr. Derzy. And this is actually the costs of O&M, which are quite high. We're talking about $19 per kilowatt per year, which is basically encircling operation, maintenance, including the cleaning, communications, and the parts actually already go beyond that number. But it is actually hidden in the warranty of inverters and panels. So when the warranty voids, you also have to add this another chunk of costs. Now, in this model, the lower the tariffs go, as you've seen, the higher, the lower the ROIs. The return of investment becomes pretty much problematic, and the only thing which you can do on the long term is actually looking on a radical reduction of all of those costs. And we also have to think about additional costs which are actually hidden. And this is very much relevant to the distributed solar PV and less so to solar fields in utility scale. And I'm talking about the part which is supervision. When you have multiple levels of solar operation, meaning there is an owner, there is also a service provider, and then sometimes there is a supervisor above it. In addition, there is probably also a supervision within each service provider company. And we also see the beginning of interest from regional energy providers, which want to know what is the situation with the solar PV in their regions. So actually taking the situation from this quite high cost model to something which is desired is quite a question of technology. And we have to break those down and understand how you can reduce those costs substantially while still improving the output of those systems without impacting the output, essentially. I will talk specifically about operation and maintenance and supervision as well. After me, Mr. Roy Sade will talk about the cleaning of the systems, which is very much costly, and it's an issue of its own. So, while breaking down, I think it's quite clear what's the operation of distributed solar PV is about. So we're talking about remote monitoring, and since we are speaking about different brands of PV inverters, as well as loggers, we're typically talking about aggregating quite several of them. We already have different aggregative remote monitoring tools on the market, but I think most of them deal with the operation itself, not beyond that. We also have to do insights, basically for each system, in order to produce the reports. Those reports are typically delivered to owners or supervisors, and then there is a need to alert the technicians in the field where they need to go, what they need to fix, and this, of course, has to be optimized. And this goes essentially to maintenance schedule of those technicians or subcontractors, which is quite common in distributed solar PV. But there are also two more issues we have to talk about, which also can be, in fact, theoretically at least, automated. So today's supervision, in fact, is quite manual, whether it's a supervision on the O&M by the company, by the service provider itself. So typically an O&M manager has to check by himself whether his team works well. And we quite frequently see the situation when roof owners check by themselves whether those reports are genuine and whether the work provided by the service provider is good enough. And we found out actually that many such roof owners, in fact, do the monitoring by themselves and spend quite a lot of time to do so. And furthermore, they also check the reports manually again to see whether everything works out as they expect. They also check electric bills. And of course, they rate the operation and maintenance quality, because in many cases, there are standards or contracts which they need to check. When the service provider is not standing up to their rating of quality, they often need to be changed. In maintenance, of course, there is possibility to automate various procedures as well. I will not talk about them too much, but basically this deals with tickets and escalation. And I will talk more about what we have developed. So our solution is industrial IoT automation, is basically utilizing the whole data from both inverters and also data which is dealing with the weather. We have to understand that in distributed solar PV, the ability to install sensors for radiation and temperature, which is quite common in solar fields, is becoming quite problematic, because you have to maintain those themselves. And when you have a lot of roofs, it is quite a challenge. So developing something which is sensorless was quite crucial for us. And this allows us full IoT automation, which also brings us to predictive maintenance. Of course, we don't need to install any sensors at all. And essentially, we move from qualitative monitoring and reports to quantitative. which also allows us predictive maintenance ability. And we also had an added value of maximum performance in many cases, except the issue of cleaning, of course, but this will be discussed later after me. So we're basically using the same platform for all levels. I will talk about them in the next slide, but this is how the platform looks like. It's more or less similar to all levels, whether it's owners, whether those are service providers or supervisors. We can simply provide different roles to everyone involved in the system, but essentially they all consume the same data. So in our view, again, we are aggregating data from different providers of inverters or loggers. We are also collecting data which is crowdsourced regarding temperature and irradiance. We completely reduce the need in installations of such sensors on each roof. We also don't need any regional weather stations. In fact, what we developed proved to be better, and it is on the level or even better than satellite sensing, which can be used for utility scale, but not for rooftops. So after the processing, we essentially provide all the information to all relevant parties, whether those are PV fleet supervisors, the managers of O&M, and the technicians themselves on the field. And the solar owners can get the reports, which they simply can read with the exact data and the exact figures without any need to check them by themselves. So basically, as mentioned, we are using two levels of technology. One is technological innovation, which is sensorless weather measurement. The other one is functional innovation, which provides also automation for supervision. And essentially, this allows us to give quantitative performance analysis and automated reports on macro scale, meaning we can provide automated management for hundreds and thousands of facilities. And this basically makes it relevant to the cities, to the city scale. So this is the outcome of what we did last year. Our average connected system size was 44 kilowatts, which is small commercial scale, but we have a wide range of them, between 4 to nearly 1 megawatt. The average number of inverters per system is 3 to 4, but again, it ranges between 1 to more than 10. What is interesting to say that the average annual system intactness, which is more or less parallel to uptime, was at 97.7%. Actually, most of the missing of the lost energy could be recovered by cleaning the dirt perfectly. Again, this will be discussed after me. And another interesting number is that 91 event days per system, there were some kind of events. So I think the major issue was actually to customize the alerts to all relevant users, because you have so many issues in each system. But most of those issues are in fact not so much severe. And essentially, you need to reduce the noise. You don't need to alert about a faulted panel every day. It's enough to alert it about once in a while. On the other hand, the faulted inverter, this has to be alerted frequently. And this basically reduces operation by more than 90%. Of course, one thing is to automate everything. Another thing is to prioritize this. And this brings the output of those facilities by, on average, 3 to 7%. In fact, we reduce degradation and improve the uptime because we discover the issues much faster and can alert them much more efficiently. What is also important, we reduce supervisory work by 83%. This proved mainly with municipal level customers because they need to check all the reports and everything involved with O&M quality. And finally, we also found out that reducing maintenance can reach nearly 40%, maintenance inspections, both due to better quality better quality monitoring, which is again automated, and by simply reducing the duplicity of technicians. We often have the case that one technician arrives and then he's identifying the issue that it actually has to do not with electric circuits, but with inverters, and then another technician from the inverter company has to come. So this can be easily reduced. We are now working in Israel. We are soon opening a representative office in European Union. So we have a strategic partnership with the Kfar Saba Economic Development Corporation. Noam will talk on behalf of them later on. We're talking about nearly 20 municipalities where governmental solar systems are installed, or about 1,000 systems overall. We're working also with D-Solar and ISC, who are commercial providers in Israel, each one with a triple-digit number of systems, mainly small commercial scale. And we also work with quite a lot of SMBs, mainly real estate companies and small industries. And we are also in process of joining more partners and customers to our portfolio. Another thing to mention, we are funded by the Israel Innovation Authority as an innovative company. We work in collaboration with some companies. VTS Energy, one of them, as Dr. Igor Derzy spoke on behalf of them, and RST, Rui will talk after me. And finally, Fronius, we had a nice collaboration on developing a REST API by the company, and we beta tested this solution. So in summary, this is what we give, and we are actually welcoming solar integrators, regional energy authorities, and solar fleet managers to talk with us and see how we can help and significantly reduce O&M and supervision costs when you manage hundreds and thousands of solar systems. So thank you, and let's move to our next speaker, Mr. Rui, who is joining us from the West Coast, California. Rui, please.
Hey everybody, let me just upload the slide deck. Hold on 1 second. Okay, good afternoon everybody. My name is Rui Sade. I'm the founder of RST Cleantech. I'm in the solar industry for the last 15 years, and 10 years ago we established the RST cleaning system. In the past, I had a solar company, and every year I had to deal with 4 major issues that really reflect the profit of the company, of the business, and also the pitch sales of our company to potential B2C clients to buy solar systems. The first problem we had to deal with is that every year we had to make a new business plan because the feed-in tariff goes down every year, and we had to do a brainstorming, and we had to check that inverters and solar panels and etc. also the price goes down, so we will have the percentage of ROI that we present the customers to be like as high as we can. The second thing that we had to deal with every year is renewing the O&M agreement, because normally it was for 1 year. It cost us a lot of manpower to go to all the customer and renew it year after year. The third problem we had to deal with is the manual wash. It was a very, very high expense to send them a manual cleaner, and it cost us a lot of money, and we dealt with it all the time. The secretary need to coordinate the washes and with the customers. Sometimes it's schools, sometimes it's public buildings, and etc. And of course, the last thing that we had to deal with is the damage, because when we send manual cleaners to clean sites of our customers, sometimes they break the tiles on the residential, they damage the roof, and then we have to fix it, and the whole business structure collapsed. So that's why I decided 10 years ago to establish RST Cleantech. We started in the year 2012. It's almost 10 years, and we installed so far over 1.5 million worldwide, million panels worldwide. And I want to show you on the slide deck the added value that we found, beside the fact that we solved the 4 problems I just talked about. So we find the problem with severe soiling problems. And normally, people wash their solar panels once or twice a year. Again, it's very expensive cost. They wash the panels during the day, so which means that they can damage the panels. All the manufacturers' warranty demand you to wash the panels either early in the morning or late at night. Our main business is Rooftop, so as you know, for rooftops late at night, you won't be able to find an insurance that will cover you. So people just wash the panels during the day when they do it, and because of the timing of the wash, which is once or twice a year, we start to do pilot tests. We did over 200 pilot tests worldwide, and we realized that in addition to the saving that RST Cleantech System implement the businesses, we also have a production increase between 5% to 15%. In some hard cases, we also saw above 25% production increase. And that's a huge effect of the RST system that we didn't even aim for it, because the business plan works by comparing capex to opex. By the saving, RST system ROI is shorter than 3 years. So after we measure the soiling rate, and we find that solution, we saw that the ROI can be even shorter. About the RST solution, first and for all, our solutions start with design of a lime scale filter that works automatic, controlled by computer, and you don't need to add salt or chemicals or those kind of things. So if you forget for 1 month to add something to the filter, you basically wash the panels with like grid water, and you can accumulate lime scales on the panels. So our filter work automatic, is very unique, and of course it's increased the energy production because it's worked periodically and you can control it by phone app. One of the main things that RST can show you the moment we do the installation is that there is no more manpower for these tasks. You don't need to hire people to do that task, which is, by the way, in the O&M industry, it's the most expensive task to do, to clean the panels. This is some pictures so your eyes can understand what I'm talking about soiling rate. We have some pictures, some of them from Latin America, from Mexico, from Israel, and you can see the difference between inverters that have been washed with RST and the rest of the inverters that have been washed once a month manually. Now, only by looking at those pictures, you can understand that this ROI calculator is very effective, because when a dirty panel produces less kilowatts than a clean panel, obviously. So you can see here on this, sorry, let's get back. You can see here, this is like 395 panels, kilowatts, sorry, 163 kilowatt system. You can see that if the production increase in 5%, which is the minimum we achieved so far, the cash back period is 2 years and 5 months. On 10%, it's 1 year and 6 months, and on 15%, it's 1 year and 2 months, which is an amazing ROI cash return. And normally, we never saw a site that we had to price the cost of RST, and the ROI was above 3 years. So it's a very short-term investment. And after 10 years in the business, I can tell you that the RST system can hold up 20 years, because after 10 years, the system look like brand new. Our system, all the parts are UV protected. It's very high quality parts, and that's why it's hold for many, many years. About RST, just a little bit. So as I told you, 10 years operation experience, 3.5 million panels clean weekly, 1.5 million panels clean on a daily basis, 3,000 RST system installed worldwide. We operate in 9 different countries. Our system have 0 maintenance visits. We have 2 patents that are related to our water systems, and we have more patents related to the components of the washing system. 0 panel warranty voided. As I mentioned before, washing the panels during the day on the hot hours can void the warranty. It's even each one of you guys can read his factory warranty on the chapter of method of cleaning and see everything is on black and white. We installed at this point 5 megawatt per week worldwide. And we consider as a worldwide leader because we are one of the oldest company in the industry, and in Israel, for example, we're the biggest one by far. So that's because our customers are pleased from the system, and they keep recommending to more and more customers to buy RST. As you can see on this picture, I just want to show you how infrastructure our system can be. First of all, you can barely see our sprinklers. As you see, I had to put arrows on the picture so you will understand that. So the system, when you look at it from a distance, you see clean panels, blue panels. You don't see our system. You need to get closer to the solar system so you will notice our system. And the reason is because we didn't want to create shades on the panels. So we had to manufacture a special sprinkler that also can get 180 degrees spray. So we will have perfect cover of the surface of the panel. And also we didn't want it to shade backwards on the, sometimes you have 2 or 3 or even 6 rows, one on top of another. So we didn't want to create shades. And then you see a clean panel, but the production doesn't increase. So we had to manufacture those special sprinklers. They work amazing. Their lifetime is 20 years. So it's a one-time thing. And again, this is our biggest advantage. The payback is less than 3 years, always. We're gonna let our customers also to separate themselves from the competition. You can also provide solutions to the customer that want to commodify it on the EPC market. You can install solar arrays that will look sharp and clean all year long. And of course, for businesses, for solar businesses, RST system can leverage the existing customers. And it's creating additional revenue because as I mentioned when I started, the main problem I had when I had a solar company is that to keep the profit from a year to year to be the same, because all the time the prices change, the feed-in tariff change, and the profit goes down. And the O&M for companies that also give an O&M service, the profit is very, very important because they work on most of the time on a minimum profit margin because of the competition in the market. An additional thing that RST create is you can extend the O&M contract with the customer for 5 to 10 years by putting RST, and instead renew it every year and spend money on sales to go and sign the contract with the customers and on all those fun stuff. Sorry, you can just place the RST system and for that to demand like a long-lasting contract. Normally all our affiliated companies that doing O&M, they achieve between 5 to 10 years agreement when they implement RST. Okay, now we have 3 reasons that makes us unique. The first one, of course, is safety. We want to reduce the labors and to make damages on the roofs. So for that, when you put automatic system, first of all, you get rid of all the manpower and all the reasons why we're damaging the rooftops. The second thing is our unique water purification system. We don't use any chemicals or corrosive in the filter. It's 100% natural. It's calibrated by computer. It's controlled by the phone app. You don't need to touch that filter when normally all the other companies, whether it's robotic or even manual washes, they use filters, and you need to keep watching that filter because it treats the water, and you don't want to get lime scales on the panels. The second reason is that we build our company and our product, based on the warranty of the tier 1 factories. We review the warranty, especially the chapter method of cleaning, and we fully warranty complement. So we designed the system to be the only system, as far as I know, up to this day, that not voiding the manufacturer warranty. So, you know, with robotic, the manufacturers claim that they don't want moving parts. When you have a manual wash, the manufacturer claims that they want it to do early in the morning, which is almost impossible. So RST is like closing that issue down, because we review the factory warranty and we design our system according to that warranty. And the last thing is that we are fitting perfectly for solar companies that also do O&M. So we increase the platform of generate new businesses, and we also separate them from the other companies. For example, if I have a distributor in Italy, and he is now competing in a market of 1,000 companies, he can put RST as an option on his price quote, and he will always be separated from the other price quotes that they have. He will always get more interest from the customer, and it put him like talking to the customer face to face instead of sending the price quote like everybody via email and pray to God, so the customer will choose their quote and not the others. So we can separate completely our affiliated companies from all the rest of the companies in the local market. So in the end, RST Cleantech, the system principle is very simple. We're fully automatic, without human intervention. Our system clean the panels with a low pressure spray and treated water. The system works at night, only at night. It cannot work during the day. When the panel is cold, the schedule can be programmed by a phone app or by a PC application. You can program the cleaning times. You can control the amount of water you want to use. And the RST system can, and done before, prevent fires. So if you have a short electricity short on the rooftop, or just a fire, you know, it's happened from time to time. The RST Cleantech system, we had 2 customers that had a fire in their place of business, and they start the system on the roof, and we pull the fire down. So it's amazing. It's an added value that we didn't count, but I put it here anyways, so you guys can see it. And that's it. So the RST system is modular. We can work on retrofit. We can also implement the system in the design stage. The technology we fit from residential to rooftops. We're doing now in Los Angeles project of 6 megawatt rooftops in industrial areas, so we can do up to lots of megawatt on the rooftops. And of course, we're doing also a small utility scales systems up to 10 megawatt. I don't know about Europe, I need to test it, but in the United States, also our customers qualify to ITC tax credit of 26%. So RST fit the ITC tax credit. You can consult your CPA to see if it's also the same at your area. That's it. I'm inviting everybody to get into our website, rstcleantech.com, watch the videos, watch the gallery. They have a lot of information over there, a lot of certifications over there. You're more than welcome to look at it. And as you can see in the last slide, you have our contact information in North America of myself, RST Cleantech, and on the Latin America operation we have. Thank you very much. And now we think it's who's coming next? Noam.
Dr. Noam Bardenhard of the Kfar Saba Economic Development Corporation. Please.
Okay. Thank you, Roy, for this valuable and very interesting presentation. I would like to present to you all with this being the last speaker, the importance of integrating novel technologies in solar PV systems. My name is Noam and I work for the Kfar Saba Economic Development Corporation, which is a leading urban execution arm in Israel and a pioneer in implementing breakthrough, innovative, sustainable economic urban technologies. And the Kfar Saba Economic Development Corporation is fully owned by the Kfar Saba municipality and serves as a bridge for the municipality with the private sector. So for all the abroad participants, here's a map of Israel where you can see Kfar Saba in the middle there. Israel is located in the eastern part of the Mediterranean Sea. And by that, we enjoy 300 sunny days a year, which is a lot. And by saying that, the state's goal of the Ministry of Energy is to achieve 30% of renewable energy by 2030. And with that goal, seeing that in Israel there are 257 municipalities, the potential in these municipalities and all the rooftops that there are in these municipalities, including also locked areas, is very, very high. So just a little bit also about Kfar Saba itself. The city is just northeast from Tel Aviv, approximately 15 kilometers from Tel Aviv. It's a part of the Sharon cluster, and there are approximately 101,000 inhabitants in the city. And it's defined as the greenest city in Israel, which is also true. Not only defined, but also true. And we enjoy today a 51% renewable energy from all the consumption of energy in the city. So the KSEDC, which is the Kfar Saba Economic Development Corporation, initiates also various projects to reduce energy consumption, not only to produce renewable energy, and also to enhance circular economy projects. So just to show you two non-solar examples, you could see on the middle picture a winter water pond that is created in order to bring the rainwater inside the aquifer instead of causing any floods in the city or just leaving the water to stream back into the sea. And beneath, you could see also a sign that says that the city does not use any herbicides for their vegetation, and Kfar Saba is the only city in Israel to do so. So we're not only solar. We don't only work on solar panels. We also do other sustainable projects, which is very important. But this webinar is about the solar panels, and just to show you some idea. So as I said, we have achieved a 51% renewable energy. And if we look at the past 10 years, we could see that between 2011 and 2019, Kfar Saba has achieved only and installed only 1 megawatt. And during the past 2 years, we have installed another 12 megawatts with 10 megawatts systems that were installed in Kfar Saba rooftops during the past 1 year. And by that, we have a solar team which developed actually a working model which includes also product and service to be used by other municipalities. You can see here on the left different logos of different municipalities that we cooperate with. And the idea is actually to escort and supervise different municipalities with the experience and the knowledge that we have accomplished during the past years. And we have at the moment plans of 30 megawatts in different municipalities, with another 60 megawatts planned only for this year in other municipalities as well. Just to bear your ears, a city with about approximately 100,000 inhabitants use more or less 25 megawatts per year. So achieving 90 megawatts is valuable for 3 big cities. So by managing such a high amount of solar systems inside the Kfar Saba municipality and also outside the Kfar Saba municipality, we need a quality control and assurance umbrella, which we have initiated during the past year, which actually is accomplished in 4 different criteria: the construction criteria, the electricity criteria, radiation, and maintenance. All these 4 criteria are very important, where we have different milestones that cover quality controls and assurance in order to manage and to supervise the construction and the installation of the PV systems along the way. Besides our solar team, we also have an innovation team, where we actually look for different startups that could assist the municipality and other municipalities in Israel to bring new novel technologies, sustainable economic technologies to the city. And we have 4 different targets and 4 different ways that we do it, programs. We have the Green Up City, which is actually an accelerator proof of concept implementation program. We have a direct implementation program, which is based on a business model which is actually made for more experienced startups. We have also our creative business partnerships and calls that we bring to different companies. I would like to share some more about the first 2. So in the POC implementation program, we actually have a 5-month program for different startups that cover different projects in the sustainable world, and one of them is also the renewable energy. So just to show you an example, a company named Radgard is one of the companies that we used, and we use them, or we promote them in order to eliminate the fear and uncertainty of radiation. As you all know, radiation comes from inverters, and it's a wide known issue. And although the radiation is very, very small, it may be a very big, big problem for different municipalities when they want to install PV systems and they need to promote the PVs with the public. So along with other stakeholders and we promote this device, which actually can detect any deviation in the radiation. And once that is happening, there is no uncertainty anymore with the radiation. Once there is a very tiny amount of radiation that is beyond the amount that is possible or that is wanted, the system knows how to shut down the whole system, and by that the radiation will stop. So that's a very important system for managing and supervising our systems and to promote the idea with other municipalities. At the moment, it's a prototype, and we're in the prototype phase, and we're about to end this phase and go into the pilot systems. And after the pilot phase, we'll have the policy validation, which will take place, receiving all the approvals that are needed. And we hope to launch the system due to December 2022. The other possibility, the other program is the direct implementation track, where Soltell is one of these startups that we use there. And here we use the city as a living lab, where it's possible for experienced startups to implement their technology inside the systems that we initiate and we established in the city. And by that, we assist them to promote the idea and check if everything is working as supposed to. And afterward, we could promote them in different municipalities. And in this program, we have at the moment 6 selected startups and 4 are in process. So as I said, the idea of managing and coordinating PV systems is actually the most important thing that we need to do. With managing such a high amount of PV systems, we need novel technologies that could enable us to manage all the systems together, if it's in dashboards and if it's in other ways and systems. And here you could see some of our PV systems in Kfar Saba. And another fact that wasn't actually been said today, but is very important to address, is the educational part, where we also try to achieve any implementation in the educational systems in order to bring children to understand and grasp the importance of the PV systems and the whole sustainable way of seeing things, hoping that they will be the next startups for the city and for the land and for the whole world. So that's about that. I would like to thank you all. And Leon, this is the time for any Q&As.
Yes, Dr. Derzy, do you have a few words to say before we begin the Q&A?
I don't have many words, but it was interesting for me. And thank you everybody for attending. And are there any questions for me? Let's start with me, with myself. Please, you can use either a chat or a questions and answers window to ask questions.
I think I already see one answered question by Andreas. Roy has already answered him.
It was, yes, for RST, it was the question for OE.
Roy, would you like to expand on that, or we would move to the next question?
I just want to say that about his question is that our system works at night. So normally the wind are very low, and our sprinklers and unique water engineering doing the trick. We placed some systems next to cement factory in Guadalajara, also in Israel, in Ramle, which is a hardcore dust, and it's very hard to remove. And the system perform amazing. Our bread and butter, it's places that have a severe problem of dirt of all kind. So our system is modular, and it fit all the type of problems you have on the cleaning issues. Of course, if you clean the solar panels, and we had one test that didn't succeed, and when we brought the expert from Suntech, we realized that the customer before cleaned his solar panel with chemicals, so he completely ruined the anti-reflect layer. That's why the panels look like it doesn't look shiny. But if you never use chemicals on your solar panels, RST will sit perfect there and do the job. And of course, if anybody have question, you can email me to the info@rstcleantech.com, and I will supply him videos and case studies, and of course lots of pictures, and I can even point him to some of the sites near him that we already put RST there. So I think that the best way is just to approach me via email, and then I can send a lot of material and reports.
Dr. Derzy, I think this question is for you. I'm now starting to check the chat. It's a little bit difficult, but a question by Ms. Hadas Marzel. Are there countries in which aggregators also own PV roofs?
Well, as you saw in my presentation, if you own PV roof, you're in the model when you are a roof owner. But obviously you can conduct business like this. So I'm sure that there are businesses that also own roofs and also provide service to other roof owners. Just different business models. I hope, Hadas, it answers your question.
I can maybe add also that municipalities, we work mainly on EPCs and renting possibilities, and it depends a lot in the municipality's investment requests. So if a municipality has the amount of money to invest in their roofs, they will probably go with an EPC system, and if not, they will rent their roof in order to receive the amounts of money from the renting, while the solar company will enjoy the money of the solar system itself.
How successful are both models relative to each other? To the best of my knowledge, in the past, it was more the issue of renting, but I think today we're moving more and more on owning the roofs by the governmental agencies and regional authorities.
Yeah, so in general speaking, the EPC system is a little bit more profitable, but again, it's like 25% more profitable. But you need to take your hand in the pocket, out of the pocket. While with renting, you don't need to invest any amount of money, and directly you start getting back the investment. So it's easier for municipalities to just rent their roofs, but it's a little bit less profitable.
Okay, I think let's move to the next question. By Iris Aviezer. I wonder, are bottlenecks for multi-residential rooftops similar in the world? So I think I will start answering about that. Maybe you can join a little bit later. And most of our talk was about governmental rooftops and commercial scale. The residential scale is, of course, under the distributed solar business. That's no question about that. But the problems which we discussed here are even more severe on the residential scale. We're speaking about even more systems. I think that Kraversky Economic Development Corporation started projects for the citizens, where they are envision 1,000 roofs in the city. We already know that in many cities in Europe, this is happening, also in the United States. There are thousands of residential roofs everywhere. And we see actually aggregators which are becoming quite big, which lease the roofs. We see this phenomenon a lot in the United States. Very big residential solar players, which basically manage everything and just rent the roofs from the owners. And on the other hand, we also see the owners which install everything, and then typically it's a kind of turnkey solution. They are being given the system by some installer with maybe 1 year or a little bit more of a warranty, and he has to manage it by himself, maybe with some monitoring app, maybe with his basic knowledge about what to do with the system, how to wash it. So responsibility is on the shoulders of the residential owner. I believe we see it quite similarly in the OECD countries. I'm not so much familiar what happens in the off-grid, mainly in Africa or Southern Asia. But in OECD countries, it's quite similar, I would say. That the bottlenecks basically are quite similar. Essentially, residential systems, even whether they are aggregated and owned by some big owners, like in the United States, by big companies, or whether they are private, the amount of money where you can invest in operation, maintenance, and supervision, the amount of money, the margin is quite low. And typically, the owners don't even know how much money they lose because of dirt, or because of faulted inverter, or because of faulted panels, or anything else. So it's a kind of problem. We think that our solution with Soltell essentially can be implemented in the residential sector. We already have one of the companies which is our customer implements this for several dozen residential facilities. But again, we have to check it on a more massive scale, maybe with one of the cities. So if anyone wants to add, you're welcome. Okay, so maybe let's move to the next question. We have some questions in the Q&A. Mr. Atilak Santos, Rui, it's for you. Can you answer, please? Can you install basically RST Cleantech solution while installing the system?
Yes, we have a lot of our customers that we send them the material to sites during the solar installation, and they do it together. It's even it's considered very cost effective because the people already on the roof, and a team of 4, by the way, can install 100 kilowatt per day. So just to add one more day for the job, they can install RST as well. So no problem to merge between the two. I think in one of the aspects that are most effective.
Well, the next question I think is for me, by Yoni Ben Metzia from Girasol.
Yes.
He's talking about operation and maintenance cost in terms of equipment quality. I think this is, of course, a known phenomenon. The lower the tariffs for solar go, the more compromise is being taken on the equipment. I'm not, criticizing anyone in the industry, but we see a lot of lower quality panels. Actually, more recently, we see less. There is a kind of standard, I think, being achieved, but we do see a lot of lower quality electric components beyond that. So while the panels and the inverters do improve, the other electric components in the systems are quite low quality. This brings RESO problems with leakage and various different issues. So how does Soltell see these issues in installation? So I think this is what brings us with the predictive maintenance. So one thing is to understand that you have a problem, you have a RESO, and when you speak about distributed solar energy systems, which are 5 to 10 years old, this becomes a problem in actually most of the systems. And the question is not so much whether there is a problem. You saw, we found 91 event days per system, which is on average 5 to 10 years old. So basically there are issues in every system, and the question is just how much does it cost you when you want to call the technician and treat the problem. So if it costs you $10 per year, you don't care. But if it costs you $1,000 per year, then you should bring a technician. And this is one of the issues we are dealing when we see RESO. So one thing again is qualitative monitoring, just identifying, okay, we have a RESO leakage problem in the system. But another way of looking at it is basically to quantify how much the leakage costs over the course of the year. And for this, you need to know how much the system has to produce optimally, and then reduce the actual production and see how much the leakage actually reduced from the system cost, from system output, excuse me. So this is what we do in Soltell. Basically, one of the issues is leakage. We quantify how much the leakage costs over the course of the year, and then it reaches a certain threshold. We just can notify the relevant owners, technical crews, and the supervisor sees that as well. And at this point, an action can be taken, a ticket can be produced. So you don't need to, manually check, just checking the air when the leakage is bad. We all know when the weather is humid, then the leakage increases. But quantifying it over the course of the year provides you the tool to basically use predictive maintenance ability to know when it is the time to treat this leakage. When do you need to bring the technician and check whether there is a leaking panel or connector anywhere in the system? And for distributed energy system, this is crucial because the cost of the technician visit is quite substantial. So you don't want to bring in just because you feel the leakage is significant. You need the actual number of how much it costs you to justify the technician to come. So I hope that answers the question. I think let's look at the next question in the chat. So question by Konstantin, I think, from how does predictive maintenance work? I think I've just answered that. So we use data from the systems. It includes generation data and of course voltage and current data, which allow us to identify which problem is actually causing the reduction of power, of output. And then when we identify which are the causes of the output reduction, we can quantify basically how much it affects the system output over the year. And then you can process this on and make it actionable. So and this also allows us to make it actionable on the massive scale without human intervention. You don't need someone to monitor a single system and quantify how much the leakage costs there. Is it much or is it not much? We all know that, for example, typical inverters just provide notifications that, okay, there is a reso problem, there is a leakage problem, but all the inverters do that, which are old enough again, do that on rainy days here in this region of the Mediterranean. But this is not actionable. You cannot do much with this data. Only when it's quantified, that's useful. Rui, did you answer about the drainage in wintertime? Yeah, I think so.
What?
The question. Yeah. No, I'm now checking the chat. So
no, that's it. I answered the question, but the thing is, when you answer the question, then it's removed the chat from open.
Yeah. I'm now checking the chat itself, and I can see that, oh, there is another question over here. I think that's for you, by Chaim. How you clean not just dust, but also oily dust from industrial emissions?
Which, yeah, I know. I answer him.
Okay.
I answer him that because we're working at night, our system operates at night. So in most places worldwide, I'm not talking about like in the middle of the desert, but we have humidity. That the humidity soft all the hardcore dirt, and when the wash starts, we just flush it out from the panel surface. And that's how it goes. We did it, and we have next to the airports when normally it's like fuel jets on the panels. We have systems that we install on agriculture areas and cement factories. So as I told Chaim, if you want, he can send me an email and I will send him back videos, pictures, case studies. We got it all. 10 years of operation, so we got a good data.
Another question to you again by Frank Osterman. Does the RST system create any noise?
No, I also answer him. If you look at it, so far I answered all the questions, but the RST system is very, very quiet. It doesn't create noise because we have also an application for residential. So, you sit in the house, you sleep at the house, and in the middle of the night, the system starts. But it doesn't create any noise, and you won't notice that it's been washed. You're only going to see in the morning the panel's clean, and then you'll understand that it's working. Okay, all those questions. Technical.
You're unmuted, Leon.
Yeah, I think we answered all the questions in the chat. We have another question by anonymous attendee. Well, I think it's just a compliment to all of us. So thank you for the compliment. PID, I think that's a question for me from Yoni. This is a good question. This is not the first time I'm being asked about PID. So PID is definitely an issue, as much as it is an issue in the utility scale and industrial scale PV. This is an issue on the roofs, and especially it's an issue on the roofs when you have hard time to access those roofs and you cannot afford the individual analysis of many roofs altogether, especially when you talk about big fleets. So, so identifying PID with our system is possible. We actually today don't differentiate the PID from any different, from any other kind of panel issue. So we do identify, by the way, panel malfunctions due to signatures in voltage and current. So for example, in mini central inverters, unlike SolarEdge or Tigo or Enphase, it's quite a challenge to identify malfunctions on panel level while doing manual monitoring. Definitely it's possible. I'm saying that as an expert on this issue who can do it manually. But you know, when you're talking about hundreds of roofs, it is simply not economical and not really feasible to inspect every roof for the voltage and for the current in each inverter, in each MPPT. It's not simply possible. So when you automate this procedure of comparing the voltages and currents, you can indeed identify anomalies in panel output, and then you can identify whether a certain array in a certain inverter has a problem. At this point, we do not differentiate whether it's a panel failure because of diode or because of any other issue, or is it PID? But theoretically, it's possible. It's just a question of algorithmics because there is a different signature for every panel malfunction. And actually, in mini central inverters, we do that on inverter, I mean, on MPPT level. But when you have a panel level definition, like in SolarEdge, you actually have to do this analysis for each and every single panel. So it's much easier to differentiate just, you know, total failure or good activity of the panel. It's actually a little bit different challenge whether it's done on SolarEdge or Tigo or an Enphase or mini central inverters. But I think our solution for mini central inverters is quite unique because there is no alternative. The other alternative is just change everything to multiple MPPT systems. So it's possible. And again, let me go back to the original question. So PID is possible to identify. Today, we identify it all together with other panel issues. So we can notify that there is a PID, that there is a panel problem. And then if it's severe enough, if it causes enough of a loss to justify a technician, then the technician will come and identify what is the reason, whether it's a faulted panel or it's a PID issue on the entire array. I hope this answered that. Dr. Derzy, would you like to answer Attila?
Okay, I see it. Well, the deviation can be pretty big. In my calculation, in anybody's calculation, if you have 3% or 2% degradation a year, then to the end of the life, after 15, 20 years, you get to 50%. So usually forecasting, they don't take this into consideration. And as I said, you are in the la la land, hoping to get big profits. but physical degradation of panels brings you to losses. So the businesses that started 10 years ago still had 10 years ago tariffs, which were pretty high. So they can afford now not only the degradation, but to replace the panels altogether. But if you look at today's tariffs, you have to be very, very careful in projecting your profits and work very hard to reduce all the losses. So I hope this answers you, Attila.
I think maybe I can add that we made a study together with RST and the Kfar Economic Development Corporation to understand a little bit the long-term effect of degradation and uptime difference between various systems. So we basically understand that from our results that we can improve with predictive maintenance and automation of monitoring. We can reduce the annual degradation by about 0.4%, because we can simply identify the issues much faster. And instead of accumulation of such issues, we can treat them on time and exactly on time, not too soon and not too late. And also Roi's solution with the automatic cleaning reduces the damage to the panels on the long term, which is another, I think, 0.1 to 0.2% degradation effect per year on the long term. So this altogether accumulates to differences of more than 10 or even 20% over the course of the lifetime. And just to understand the numbers in Igor's presentation, the average degradation of systems in the field, I mean distributed energy systems, reaches on average 2% per year. This is much higher than what is proposed in sales presentations by installers and by panel manufacturers. So first of all, panel degradation is one issue, but the whole system degradation is completely another issue. And often we see systems which are neglected to this level or another, which have a lot of faulted elements, a lot of faulted components, and reach, I saw systems at 50% uptime after just 7 years. So today we see a lot of systems just being altogether replaced, all components altogether, panels, connectors, inverters, everything. But those, again, as you said, those are high tariff systems. And in 10 years, the situation will be completely different, because at lower tariffs, it will not be worth it. That's it about this issue.
Well, I can show you shortly in Excel, Attila, if you like. And we can end at this. Share screen. Okay. Well, look at Excel, and you can see that the degradation that in the first year is small. After 20 years, it's pretty large. Also, this is your projected income, but after a long time, you can get to losses. If you play with the numbers, wait a second, I have too many windows. It's pretty difficult. This is the first time I'm doing it. Okay, so now you can play with the numbers and reduce the annual degradation to 1% of the operation costs. Well, sorry, 1% of the
income.
No, 1% of the performance.
1% of the performance, that's correct.
And still you are 20, after 20 years, you are at 20% losses. It's crazy. And you better not sleep and take care of it. And there are various reasons, physical reasons for degradation, neglecting cleaning, cleaning with not good materials, neglecting electricity issues, weather issues, buying buying cheap equipment. Somebody asked a question about it. I think you spend less money in the beginning, then you have more degradation, and you have to think about all this stuff in advance before you start your business. And better to take a good advisor to help you with this before you start a business.
Yes, but there is, I think, the fundamental issue in the distributed solar PV is that for many systems, especially residential, but also small commercial, you often cannot afford an advisor. And that's, I think, a fundamental problem. And then you have to deal with those issues. The situation is much better in the municipal level or larger commercial level when you have owners with significant rooftops. But on residential scale, for single roof owners, it's simply a very problematic issue. And then we have to deal with the consequences. So I think we're done with today's webinar. Thank you all the participants.
It's nice.
What?
More than an hour, hour and a half.
Yes. So thank you all the participants and thank you all the attendees. I hope it was I hope it was interesting for everyone. We were asked for presentation, so I think we will send presentations if you are okay with that.
Yes.
Let me know.
No problem.
Yeah. So thank you very much once again, and hopefully we will do another webinar on the issue. Goodbye. Have a nice morning or evening, depends on where you are.
Bye, guys.
Thank you.
Bye-bye.
Goodbye.